Hello everybody, and welcome to the PoorMansChemist. In this video, we are going to be converting this here thallium 1 chloride into thallic oxide, so thallium 3 oxide. I came across this actually on another channel on YouTube. They did this experiment on small scale, like in micro scale basically, and I was very intrigued by it because if this works, it should solve the halide problem. Now, a lot of metals you can recycle just by reducing them back to their metallic state. You can do this with thallium as well, but the problem is, unlike many other metals, thallium metal particles clump up like crazy. Normally, you've got to sit there like with palladium. You got to sit there and stir that shit for fucking hours to get it to clump up. With thallium, it happens in just a couple minutes. And it happens so fast that it will trap little bits of the solution inside the metal itself. And then you dry it out. And no matter how much you try to wash it, you can't get it out. So you dry it out, and then you go to use the thallium again. You dissolve it in some acid, and poof. Some of it always drops out as the goddamn halide, and it always fucks up my stoichiometric calculations. So I have looked long and hard for ways to get around this problem. I did a video before where I made thallium 1 chromate and then tried to calcine that one to the thallium 3 oxide. As I recall, we got copious amounts of death vapor off that, and that was all rather terrifying. So, yeah, that wasn't a viable way. This, I hope, is going to be much more successful. Because if it isn't, I've only got like one other trick up my sleeve. But let's hope that this works. So I didn't weigh how much I had because I'm quite paranoid about creating dust. Remember, I don't have the kind of facilities I had at the old house. So, you know, it's just really don't want to poison my environment. Like at the old place, I could just let it all wash away because it was like just a tiny little bit and I didn't really worry about it. Here, that's the problem with working inside with heavy metals or in a confined space, is that if there's some kind of contamination, it's just going to stay there until the end of time. And like dealing with it can become extremely difficult. So, what I did was I poured out all that I had and put it into this beaker with water, and I have tried to get it all to dissolve by heating it up. Thallium chloride is somewhat soluble in very hot water, like near boiling. You can get a couple grams, like I think about 2.5 grams to go for every 100 mils. And we really do want to get this shit to dissolve as much as possible, because my worry is that if we start converting it to the oxide while there's undissolved thallium chloride in there, the oxide will passivate the halide particles and the reaction will not go to completion. Now, if it doesn't, is it the end of the world? No, because I was thinking of taking this thallium 3 oxide once we get it, and then maybe in this, probably in a separate video, converting that to thallium 3 nitrate trihydrate, and then using that to create thallium 3 arsenate, which is one of those unholy marriages of like a really toxic heavy metal and a really toxic metalloid. So yeah, awesomeness. Let's make some wildly poisonous shit. So the first step here is to make our solution alkaline. It has to be alkaline for this to work. Then once we've made it alkaline and heated it up to get as much of the thallium 1 chloride to dissolve as possible, we're going to add hydrogen peroxide to this bitch, the 35% kind that I got from Walmart. Yes, you can mail order 35% hydrogen peroxide from Walmart. God, I love America. So yeah, we're going to add that in there, and that should convert the chloride to the oxide, theoretically. I don't know. They did it with, on the other channel, Colorful Chemistry, they did it with thallium nitrate, but we're just going to really hope this works. It seemed like it did when I did it in a test tube, so I'm optimistic. Anyway, here we go. I guess if it doesn't work, I'll have a nice big thallium mess to deal with. Ugh. It's alright, wouldn't be the first time. Oh, well, okay. Interesting things are already happening. Didn't do this before. What is going on? Huh. I didn't notice a color change in the solution in the test tube. But with the test tube, I just did it straight away, and there wasn't any thallium 1 chloride in solution already. Even though there won't be much, there will be some. Oh yes, if you repeat any of my work, especially with thallium, remember, gloves do not protect you. They buy you time. Do not trust gloves to protect you with this shit, please, or any other kind of PPE. I am going to be making a rant video later about all these motherfuckers making these videos. Oh my god, thallium is the most evil metal in the world, man. Shut the fuck up. It's always by some painted dildo that has never actually worked with this shit a day in their life. And I swear to God, they are walking, talking wastes of carbon. Just making people stupid for clicks. Yeah, you search for thallium on YouTube, their shit shows up. But you don't get any of my goddamn videos where we actually educate you about this element. No. Because over here, we get rid of some of the fear and replace it with knowledge. And we can't have that, now can we? Anyway, I will be back. The next step will be to heat this bitch up. And I'm going to double check the pH just to make sure it's good and alkaline. It should be. I mean, should have been more or less neutral to start with. And yeah, we're just going to heat this up and get as much of this shit as possible to dissolve so that we can proceed to the next step. All right, so here we go. We are going to add our 35% hydrogen peroxide to this. Whoa! Oh my God. What tiny dick little dildo has to have fucking shit that loud? Like, what a fucking asshole. I don't know who that is, but that cocksucker does that shit at any hour of the day and night, tearing around here. It's like, you fucking fag. Again, like South Park nailed it. Wow, that is some death aerosol right there. Let's just stand far back from that shit. That is some evil effervescence right there. That is very dangerous. Boy, I'm glad I didn't try to do that shit inside. I'm a little terrified doing it out here. And of course, as soon as it starts fizzing like that, the wind changes direction, because of course it does. But this is everything I had hoped for. Oh, wow, yeah. That is terrifying. But awesome. Quite awesome. Jesus Christ. Dude, this is fucking terrifying. Is that just steam? Okay, let's kill the heat here. even if it is steam, that does not mean it's safe. Lady and gentlemen, I think that we have done it. Actually, is there a lady that watches this channel? I don't know. If we got any females out there, let us know in the comments, because so far as I know, it's a sausage fest on this channel. Not that I'm complaining. I am all about a good sausage fest, don't get me wrong. Okay, I am really tired of that shit. It's scaring the fucking shit out of me. And it's probably just steam, but I don't care. I really don't need thallium poisoning from inhaling aerosol droplets. God, that would suck. Maybe I should have just been doing this the whole time. Okay, I'm gonna guess that's probably enough since we're not getting any brown in our foam anymore. That is beautiful. Look at that shit. That is textbook. All right, well, let's let that settle, and then we'll decant the liquid, dispose of it, and go from there. Okay, people, so here is our thallium-3 oxide suspended in a small amount of distilled water, and we are going to very carefully add some concentrated nitric acid to this, because I'm not 100% sure how vigorous this reaction is going to be. Okay. Seems fairly tame so far. Now this, hello, come on camera. This thallium oxide has been sitting for a while, about a week. I hadn't had a chance to do anything with it, but it has stayed in water the whole time. So it has not been dried out, which, from what I've read, would make it less reactive. Let's try warming it up a little bit and seeing what that gets us. All right, I've transferred this to a 400 ml beaker because I am very worried about splatter. I'm going through my supply of gloves kind of quickly here, but this is turning out to be kind of a messy process. I'm really beginning to regret the fact that I did not react this with the nitric acid immediately. But it does seem to be reacting slowly but surely. Let's just hope that this doesn't become vigorous at any point. Right now, I've got it heated on about medium heat. Hopefully that will drive off some of the water concentrating the acid, and this stuff will start to dissolve. I mean, that's all the nitric acid I've got over there, and I don't have any potassium nitrate, nor do I really have the money to go get any because I spent all the rest of the money you guys have sent on other chems already. I don't know why it didn't occur to me to make one of those potassium nitrate. I wish I could say there was some master plan behind that, but no, it was just a dumb oversight. I mean, I got all kinds of other cool shit, like sodium bromate and sodium iodate and sodium tetrafluoroborate, but I did not think to get more potassium nitrate. All right, finally, after 2 days of trying, the trick was adding a lot more nitric acid and heating it more strongly. This has got to be close to the temperature of boiling water at this point. I have that roughly marked there on the knob where that is, and you know, it's just a little bit above that. I have been very nervous about heating it this strongly just because I don't want it to splatter or splash or cause a problem. And one of the reasons I had to increase the volume as much as I did is because this stir plate goes from like fast to super fast. There is no slow speed on it. And so every now and again, you will get a little droplet that's propelled at some freak velocity out of there that will land on the table, the hot plate, God only knows what else. So, yeah. While the toxic properties of thallium have been mythologized and exaggerated, it's not like they're not based in fact at all. Obviously, yes, it is toxic as hell. It is a contact poison, and even though it is not dimethyl mercury levels of contact poison like people seem to imagine that it is, it will still, getting it on your skin and you not noticing it isn't the best thing in the world. Clearly there is some level that you can do that and get away with it, at least a little bit, because thallium sulfate was used as a hair removal agent by ladies like 100 years ago, maybe a little more. It's one of the ways they figured out it was a contact poison in the first place. So clearly, there is some threshold you have to cross before it is going to start to cause problems. But I don't really know where that threshold is because there are so many variables that are involved in the rate at which something is absorbed through the skin. That's why it is so very difficult to find any kind of data quantifying this. So yeah. It probably wouldn't be hard to accidentally cross that line. So, while we don't want to treat it like it's the most evil metal ever, the most toxic metal on Earth, and whatever the other bullshit dumbasses want to make videos saying, that is not to say that it is not hazardous, because it definitely is. Okay, so we got chased inside by the thunderstorms, but I think we can wrap this up in here without any issues. So what I've decided to do is to just work with the thallium-3 nitrate dissolved in nitric acid. I tested this on a small scale in a test tube yesterday, and the reaction works just fine. So I am not going to try to isolate this stuff. This shit right here is picky as fuck, man. It is instantly hydrolyzed by water, like the moment it touches it. Even mild heat seems to cause it to break down to the oxide. It is not the most stable thing in the world. And it was taking a ridiculous amount of time to try to evaporate it down and get it to crystallize, which it just will not do for nothing. On the positive side, I know, it reassures me that this is indeed thallium-3 nitrate, because thallium-1 nitrate would have precipitated out all over the place by now. So what we've got here is some arsenic acid that I made yesterday by dissolving 46 grams of arsenic pentoxide in 200 mils of water. I was going for a 1 molar solution of arsenic acid, but that didn't really work out because after I heated it up and got everything to dissolve, I filtered it through some glass wool, and that removed this brown impurity. Now, I didn't buy that arsenic pentoxide. That was actually a gift from the gayest person on YouTube, I think his screen name is. He sent me the arsenic pentoxide and the arsenic trioxide and a couple of organo-arsenic compounds that I just haven't done anything with. So, I mean, it was a gift. Can't really complain about that too much. And it doesn't seem to have caused a problem in the past, so I'm not going to stress over it too much. And yes, I am going to keep arsenic acid in my collection permanently now because that just looks so fucking cool on the shelf. A bottle of arsenic acid. I love it. All right, so let's turn on the stirring here, and hopefully everything works just as well as it did when I tried it in a test tube yesterday. Here we go. Well, what the fuck? Oh man, don't tell me the volume is too high on this. No, there we go. Yay! Boy, that made me nervous there for a second. It was slow to precipitate yesterday as well. I probably wasted some arsenic acid there, but I don't care. I have been working on this project for weeks, man. I just want it to work. There we go, people. That is thallium-3 arsenate right there. It is a very light yellow, exactly like the literature describes. There we go. Look at that shit. Finally. Holy crap. That scared the crap out of me when it didn't precipitate. It's like, no! I don't even care if I use too much arsenic acid. See, the thing is, the literature says that this stuff will be decomposed by hydrochloric acid. So I was very nervous that the excess nitric acid was going to cause a problem. But I guess not. Oh, that is fucking awesome. Now, if it's like it was yesterday, it was very heavy and settled out pretty quickly in the test tube. And it looks like it's going to do the exact same thing here. I'm going to let this sit for a minute and I'll come back and we'll see how much of it settles out. All right, people. So as you can see, it settles out pretty quickly. I just had this stirring for a minute because I poured some into a vial to keep. Got some right here. I'm going to keep this. Hopefully it will be stable if I store it under the solution it precipitated from. That's usually the case. So I'm just going to keep this in my collection because it's Thallic arsenate. This is actually it, people. We did it. We combined thallium and arsenic into one compound. This stuff is basically death powder. This is great. So fucking awesome. Oh, wow, man. Look at that. It seems like it takes time for it all to kind of precipitate and coagulate. But if you give it that time, about 10 minutes or so, as you can see, it's not too hard to get it. That's so fucking awesome. That is so great. Oh, that is beautiful, man. We did it. We finally fucking did it after all this fucking work. Holy shit. And it's exactly like the literature described. A light, like lemon yellow solid that was kind of gelatinous. And that's exactly, oh, this is so fucking awesome. This is just great. Oh, that's beautiful. Well, let's go ahead and let's finish this up by converting all of this to thallium-3 hydroxide, which is one of the most insoluble compounds I've ever come across. It's got a KSP of something like 10 to the negative 46th power. Like that is just crazy. When I tested this on a small scale yesterday, it precipitated right out, no problem. I got the idea for this just because the literature said that if you react this with alkali, thallic hydroxide precipitates out. So, oh, that is so fucking cool though, man. Look at that shit. We actually got it. We fucking did it, man. We made thallium-3 arsenate. Oh, that is just tits. God damn, that is awesome. All right. I do hate that I had to use so much arsenic pentoxide for this just to basically destroy it, but I don't care. I don't care. I've got a sample of it. I've got proof that I made it. It is yet another thallium compound I can add to the list of thallium compounds I have made. I think we're definitely over 20 at this point. We might be getting close to 30. This is fucking awesome. This is just so wonderful. I wonder if I can recover that arsenic. Here we go. This is very strong aqueous sodium hydroxide, probably something close to 50%. Oh, wow. She got hot and goopy, boy. Okay. Come on, stir bar, you can do it. Yes, finally. All right. I wasn't going to filter this out, but I really would like to try to recover some of that arsenic if at all possible. So we are going to filter it after all. We got it all set up here for simple gravity filtration. And let's see how this works. Oh, wow. That was not what I was expecting. Damn. This shit filters really easily. Whoa. Yeah, I was not expecting that at all. Don't you fall over, you fucker. And this should basically be quantitative. I mean, that should be all the thallium that was in there. Oh, it's going to be fun trying to clean this glassware. All right, well, hopefully it is not hydrolyzed by water. Doesn't look like it is. I cannot believe how easy this is to do. This is ridiculous. This is one of the easiest things to filter I've ever seen. Holy shit. This is recording, right? Because nobody's going to believe me if I don't. Holy crap. Boy, this is a rare thing right here. I can't tell you. I don't think I've ever seen one this easy to filter. Holy fuck. Wow. This is fantastic. And you want to know what else it is? It is 100% the solution to the halide problem when it comes to recycling thallium. We have done it, people. We have figured out a pathway for recycling thallium that gets rid of those goddamn halide ions. That is fucking tits, man. That water is, look at that. It's crystal clear. The filtrate's crystal clear. I can't believe this. This is wild. Well, I'm glad I decided to filter it. Otherwise, we'd have never seen that. Holy fuck. Wow. That is crazy. All right, people. There we have it. Thallic arsenate and thallic hydroxide. And also thallic nitrate and thallic oxide on the way here. So there we go. That is so cool. That is awesome. After all this fucking work, finally. This was a very expensive and time-consuming project, but it worked beautifully in the end. This is fucking great, man. I was really worried there for a minute. So, yay, we did it. If you like this video, give it a thumbs up, subscribe, comment, share the video. Please donate a few bucks if you are enjoying this content, because again, it is extremely time consuming and expensive to produce. And until the next one, you guys, I see you later. Oh, this is great, man. It actually fucking worked. Thank God.